Thinking. And there it goes. Hello, I'm here today for another Kaggle Coffee Chat with Peter Wang, who some of you in the Kaggle community may know as the co-founder and current CTO of Anaconda. And for people who may not be super familiar with Anaconda, we have some like diehard R people. Do you want to give us a quick intro?
Yeah, sure. So we are we've been involved in the data science and computational, numerical computational aspects of the Python language for quite some time. But we're actually a polymathic sort of company. So we support multiple languages with Anaconda itself, although obviously it's more popular and well known in the Python community. And we do a lot of open source projects also in the Python community. But most of our actual customers, when they buy our enterprise platform, we walk into places where, for the most part, it's hybrid Python and R. Very few places are only a single language. So we think of ourselves as a general sort of big tent data science software company.
Yeah, excellent. And also really committed to open source. Because I definitely think of like Anaconda as one of the big stars in the Python open source.
Oh, shucks. Yeah, thanks. Well, we've been pushing open source for a long time, and I think one of the things that people who are not from the machine learning or data science community might not realize is that in the traditional software and IT infrastructure space, open source has been around for a long time. Obviously, with Linux and a number of different things. But for a lot of folks, there, open source really is a way for it's sort of like a cultural kind of thing, and a lot of times it's lone hackers building open source things to be either from a point of economic or political sort of rebellion, but actually in the machine learning data science space, and certainly in the computational sciences, open source is a place where innovation is happening, right? It's not just let's do free community sourced one-offs that are sort of like weird variants of some high quality commercial thing. It's actually the high quality stuff is in the open source. It's where the innovation is happening. So I think that's something which we may take for granted in the machine learning community, but it's certainly not a universal. If you look at things like software languages and innovation happening in like JavaScript and whatnot, there's a lot of reinventing of wheels and people just building yet another piece of open source for whatever reasons. But in the machine learning space, it's definitely a place of innovation.
Yeah, I'm trying to think of a machine learning framework that's not open source, and I'm having a little bit of difficulty. Maybe driverless AI from H2O.
Well, H2O does a lot of open source stuff, but the driverless AI stuff, I think, that's a product offering. So maybe that's not open source. I don't know, but
it's also not really a framework.
No.
Yeah.
So, I mean, Data Robot's not open source, right? They use a lot of open source tools. Our enterprise platform is not open source, but those are sort of like products and not really the frameworks, right?
Yeah.
Yeah.
Like quality of life stuff and infrastructure, and not so much the like core code you need to use to build things. So, well, what things I mean.
Actually, the biggest. I would say it's not really a framework per se, but actually GitHub is not open source, right? So all the code that handles the issue trackers, the code that the concept of pull request was invented by GitHub. It's not integral to Git, and that was sort of that was, I wouldn't say foisted, but it was certainly a GitHub-ism that has been exported to the open source community at large. But if you were to go in a time machine and jump back 10 years ago, people were doing open source development using mailing lists, using things like Subversion and Track, Redmine. We used tools like that, and there wasn't really the concept of a pull request. Like, people communicated on mailing lists. There was a dev and a user discuss sort of mailing list, and that's kind of how we did it there. But GitHub.com itself is closed source, very much closed source, and a lot of the things that we learn, like we teach, students and new data scientists how to use these different things, but really we're teaching them how to use a proprietary tool. So that is something that sort of to be aware of.
Yeah, interesting. I guess I sort of knew that conceptually, but it never really.
Right. Yeah, it's part of the water, so it's hard to notice.
Yeah, and so something that as the longer I spend in industry, it becomes more and more apparent to me the difference between sort of closed source and open source tools is that a lot of closed source tools have like a very explicit model for how they're going to continue to offer support and do new features. So I'm thinking like MATLAB here, which is not my favorite language for like aesthetic reasons. And of course, it's pretty expensive, but the fact that you're paying for your MATLAB license every year for your lab is how they maintain the project. That's where they get the money and have the ability to hire people. Whereas open source projects, and I'm thinking about this particularly in relation to Jupyter, it's just like people giving the gift of their time and energy. And I think it's, especially as a data scientist, it can be a little bit intimidating for me to get really involved in open source outside of like, designing educational materials because like I'm not a software engineer, man. I don't know how to write. I do know how to write unit tests. I just generally choose not to.
Right.
But if you want to talk to the data science community about how they can best support open source work that we all use, like who doesn't use pandas?
Right. So I was just jotting down some notes as you were talking here. I think you put that really well, and I think a lot of people don't maybe don't necessarily think about that when you do obtain a piece of software or even a piece of hardware from a commercial vendor, you're very much aware that you're entering into some kind of relationship with a vendor around an artifact, right? So we'll call the piece of software, let's say MATLAB, the artifact, and there's the vendor. And your participation, in a sense, really is around the transaction. You pay for the license. Back in the old days, you get a dongle, to plug in the port of the back of your computer, and then only you get to use that copy of the software. But I think if we use that framing and we look at what happens in the open source community, the open source communities around these pieces of software, they tend to emphasize participation in the community and the innovation community and the maintenance community more than they emphasize the software artifact itself, to maybe for better and for worse. So you have a very good question about like, what is, when I download a version of Pandas, right? What is the covenant here, like in terms of the long-term maintenance? If I go and I build a software, I want to go and build a machine learning startup, and I, put all my data pipelines around some Pandas here and some Dask there. I got some Jupyter notebooks that capture kind of the workflow. There's sort of this expectation, an implicit one, and perhaps not a correct one, that this stuff will just keep working, and that I can, because I got it for free, it will be maintained for free forever in perpetuity. And maybe like when we say it like that, that sounds very like, oh, well, maybe that's not going to actually happen. But we don't think about it like that, right? Just like with the GitHub thing, we think about, oh, here's some free code. I build my thing on the free code. It works today. Therefore, standard human fallacy, I expect it'll work tomorrow. And so, so that relationship that we have with the open source artifact is very different, because the communities that produce them, they expect you to have a relationship with the community. And on the basis of that, you get the artifact. It's almost like, maybe this is a really poor metaphor, but I'm just sort of winging it here. But if you think about a communion wafer, right? I would say that's an artifact of the Catholic Church, but it's more than just a wafer. And you can't just barge into a Catholic church and start eating crackers. Like it's sort of, that cracker is received as part of this overall participation in the community. And I would say that the open source software community that produces things like Jupyter or Pandas, NumPy, any of these things, scikit-learn, these are communities, and we get artifacts from them. They don't necessarily insist on everyone registering in order to download the piece of software. There are some open source packages or communities that do that, okay? But that's not the model for most of the Python data science community. So when you go and you get these things, you're getting it for free. You're getting like a free communion wafer, but you may be not realizing on the back end of it, there's actually sort of this covenant, which is that if you want to give us feedback on that cracker or that wafer, here's how you do it, right? You got to show up for mass. And so I think that, that broader question you have about what, how people should think about it, we should really be careful or be intentional, right, and deliberate in looking at, are we thinking about just this code as an artifact? And if so, then I paid nothing for it, and it's on me. If I want to go build a house from it and the tool starts breaking, it's on me to fix it. If I don't feel like I can fix it, if I'm not a software engineer, I can't really go and fix some inner like loop inside NumPy, well, then I'm looking to the community for help. And so now I show up and I'm part of a community. And so I can ask questions. I'm part of the user community. I can offer feedback like, hey, I try to use this model for this thing, and gosh, I wish it did this thing like they do in R, let's say. And then you can offer that feedback. You should do it thoughtfully and respectfully, though, because the ethos of the community is one of participation, not one of servitude, right? The maintainer's not there to serve you. But I mean, to your other question about like how can you contribute because you're not a software developer, well, the community is much more than just the software. There's a community of practice, and I think the things you do around facilitating conversations like this, the things you do around teaching and just being a member of Kaggle and being, part of a large organization that promotes learning and practice around data science, that's critically important, right? I mean, if you think about how much more work the scikit-learn devs would have to do if they had to write all the example notebooks that are posted for free on Kaggle. So, we're all sort of part of a large participatory community, and we all benefit from each other's contributions. And I think that actually one thing to particularly stress to people who are new to the ecosystem is that the beginner's mind actually has a lot of really beautiful things that tend to erode once you become an expert. Because the beginner, or someone who's novice, let's say beginner sounds a little bit pejorative. If you're novice to these tools, you may have a point of view about how they should work, like what fits better for you as someone coming new to them with a fresh set of eyes. That's very precious and very rare. So if you can actually articulate what it is how you would like to see this work better, what you would have expected for it to do under these circumstances, that kind of feedback, again, expressed thoughtfully, not from a hey, you all should do this because this makes more sense to me. But I think if you could capture that kind of feedback, that's like gold for the developers, because the developers are so rich, so like deeply embedded in the tools. They really can't. They don't know what spelling makes the most sense for people, at some point, because for them it all looks the same. They're like looking at the matrix. It's all just green letters everywhere, right? So I think it's that's a point of feedback. Thoughtful user feedback like that can go a long way. I think you'd be surprised. Maybe the people who are watching this would be surprised at just how far well-crafted feedback can go in terms of shaping the future of a tool.
And so some good places to give people that feedback would be maybe GitHub.
Yes, I think we're trying to now the community, I think more and more is trying to push to mailing lists and discourse just to keep the issue tracker things, but like to keep the issues being very much just about the issues. But some projects still use the issue tracker. If there's an appropriate tag, I would certainly encourage an enhancement request or something like that. But yeah, I mean that would be a good place to start.
And you say discourse or Discord?
Discourse. So Discord, yeah.
Voice chat servers. Okay.
That's right.
Okay, because I could see that you just sort of like pop in and people are chatting about whatever open source, and you're like, hey, got a
that's great too. If you want the real time, not all the projects have the staff to maintain kind of the constant feedback on Gitter or on Discord, but the Python community, so the Python core dev, they use Discourse as a place to host these conversations. That's a little bit lower friction and lower barrier to entry than a mailing list. And so so I think that's where some of the Python the PyData SciPy projects are moving to as well.
Yeah, excellent. I think that's really good feedback and nice actionable things that people can take forward with them. Yeah, and I don't know, I'd just be interested to hear your thoughts. I know, again, we keep talking about GitHub a lot. They recently launched, I think of it like Patreon, but for open source projects.
Right.
Are there other ways to, if people are able to financially contribute, that make sense?
Yeah, so I would be remiss if I didn't, point people to NumFocus as a great place to donate and support the projects. It's a really nice clearinghouse to just get money going to various projects directly to the project maintainers. Now, one thing that NumFocus does is that it insists on the projects that it sponsors to have a governance, an explicit governance and sort of fiscal handling sort of policy in place. And small projects, big projects, they all sort of have to have that in place before NumFocus will accept funds for them. And it seems like bureaucratic and administrative overhead, but it's actually really, really critical for the development community around a project to think about that and to have something codified so that then everyone knows what the ground rules are. And I think this is one of the problems, not problems, but I think this is one of the challenges that is going to start emerging as projects start adopting the GitHub support model, which is, hey, cool, we got this money, now what do we do with it? right?
Yeah.
And so I think that Devin and others at GitHub who launched this feature, major kudos to them for making a major impact on the sustainability and funding of open source. But I think it's only the first step. I think it's really critical to give them the communities the tools to talk about how they want to disperse those funds, what the ground rules are. And actually, I think it's also, this is going to sound a little bit weird, I think it's important to offer tools for communities to opt out of that, for projects to say, we don't actually want money. If you want to support our project, either hire one of our devs or do a support contract with one of these 2 or 3 people that we feel know what they're doing with this project. And we actually don't excuse me, we don't need the beer money. We don't need the $5, $10 a month coming in here or there. Here's my SoundCloud if you want to really support my personal project. But otherwise, I think it would be good to have projects be able to do that as well. Because I think this is something that Fernando Perez, the creator of Jupyter, one of the creators of Jupyter, said a while back. He said, money can actually just create problems for projects that are participatory, these communities. If you just drop a bunch of money on people, it may actually create much more damage than do good, which is really ironic and really disheartening, but it's true. Because I think the thing to realize is that the reason I think the open source ecosystem has been so great at innovation is because it doesn't actually buy into traditional sort of capitalism, socialism, labor economics.
Yeah.
With software, in the words of John Perry Barlow, who's one of the founders of the EFF, do you have an EFF sticker? I thought I saw an EFF sticker on your. No, I mean,
no, I think I might have been somebody else.
Okay, sorry, I thought I saw an EFF sticker. Anyway, John Perry Barlow had this great thing. He was one of the people that sort of really pushed this idea that information wants to be free, the idea of selling wine without bottles. That we have something that's a high value, but it costs you nothing. It's not scarce, right? And so the open source community, I think, has shown that we can create massive innovation by leveraging off of each other's work in a way that naturally lines up with the non-scarcity of software and information. The instant you put dollars in there, or the instant you start pegging people's contributions based on labor hours they put into whatever, now you're starting to quantify things from the perspective of using the paradigms of labor economics, which capitalism understands, which most of us have an understanding of because we generally get paid for our labor, right? So I think that's something that is unavoidable and can be done if done artfully, but also can very much, unfortunately, it can corrupt the conversation or corrupt that natural free gift economy sort of collaboration. A very concrete question is if there's paid contributors and they're able to contribute full time because they're paid, and you have volunteer contributors who may be just as smart and have been in the project for longer, their voice now gets crowded out because they're not getting paid to work on the project. And is that better for the project? Is that better for the long-term health of the ecosystem around that, or the community around that project? The answer is not necessarily yes, right? So these are the kinds of dynamics that we have to really be careful of as we start injecting money into the gift economy.
Yeah, definitely. Lots of really good points there that I hadn't really thought deeply about. So a lot to take with me. Is there anything in particular you'd like to share with the Kaggle community? I know one thing, I don't know if this is something you want to talk about, but something that I constantly get questions about, and it seems like it is the Wild West out there, is pipeline management and versioning and figuring out how to set up experiments and then run them in a nice controlled way. So if there's a breadcrumb for you, feel free to swim around it.
Yes, well, that is, gosh, I think that's an area that's ripe for innovation right now. It is unfortunately going to be a while before that settles out, I think, because the thing that's happening right now, and this is something, maybe this is the breadcrumb. Okay, I've got the breadcrumb now. You got me hooked. So conceptually, I think the thing for all of the machine learning and data science developers out there to think about, or practitioners to think about, is that the machine learning and data science activity around software and that use of computational resources, that's a relatively new sector in terms of traditional IT footprint. Traditional IT footprint is there to, turn SQL tables into more SQL tables, run a bunch of Java code to build business apps and things like that. And the machine learning and data science stuff has just like landed like this giant asteroid, right, crashing into this thing. And so no one there has any idea how to manage any of this stuff, because they look at the code that data scientists produce and they're like, well, this is code that we can read, and it's maybe a little bit terrible, and none of us would have written it this way, but this is really apparently magical and important that we run this code in production. And so there's questions of how you do that, right? They look at Jupyter notebooks. They have no idea what to do with notebook, right? And so a lot of the things that we're doing in the data science world, they are relatively new to most businesses. And if you're lucky enough to be in a young startup or a youngish tech company that really prizes and understands and values the data science kind of center activity, then they'll support you. I mean, they're going to completely support you with resources and budget and everything. And you have all sorts of cross collaborations, and that's all great. If you go into a more traditional business, one that's been around for, let's say, a few decades or maybe a century, they're going to have well-established swim lanes, and data science machine learning doesn't fit into any of those swim lanes just yet. So all of the things that you need to do as a data scientist, you're going to be stepping on toes. You're going to be bopping other people in their swim lanes, right? You're going to have data management concerns and needs that don't look like traditional database management. And the DBA is going to be mad at you for, why do you want these massive data pulls and massive table dumps and table scans, and you're storing all this stuff denormalized? Why? It doesn't make any sense. Of course, it makes sense as data scientists, because we want to cluster on all these variables, right? Likewise with IT, they're going to say, well, how many machines do you need? And you're like, well, this week I need this, but next week maybe that. And they're going to be like, you're completely insane, right? So no one knows. And again, I already talked about the software developers. They see you typing code into a code editor. They see you checking code into GitHub. And then they think you're a coder, but you're really not. And so no one really knows how to wrap their heads around who you are as a practitioner. So when you go in and talk about, oh, here's what I need workflow management and pipeline management for my stuff, which touches all of these things, every single one of them will surface up a solution that works for their narrow sliver or siloed portion of the problem, right? If you look at model management, that term has been around for a very long time. And that term has, back in the day, I mean, it's still around, but PMML, right? All the databases with PMML. And everyone sort of understands what a model is from the old school SAS and SPSS and predictive analytics kind of world. But when data scientists talk about it, they sort of mean something bigger and broader than that, because they want to have online testing. They want to have, alerting and notification. They want to be able to look at what version of what data set fed what model and how is it performing this week versus last week. And, all these kinds of things, that's more than just checking a PM, like putting PMML into a database, right? So everyone, and then the IT folks, and I see you guys using Docker or Kubernetes, and they're like, oh, this is great. You guys know how to use Docker. Let's Docker the world. Check everything into this Docker hub. And you're like, well, that doesn't actually solve all my problems. And so every single one of these silos, they're going to have a hard time surfacing up a whole solution for you. So the data science world has to make its own. And this is where projects like, Seldon, Polyaxon, this is where the, TFX or TensorFlow extended the TFX stuff. Like everyone's got sort of tools that they're throwing into this space. I think Michelangelo from Uber. There's a lot of frameworks coming around for these kinds of things. We're working on a few at Anaconda. We're trying to sort of pick, which of these are best of breed and which ones, have ideas that we can learn from. It's very much a rapidly evolving space. This is all a long-winded way of saying there's not a single answer, except it's good to know. I think it's really good to know why there isn't a single answer. Why can't you just do this or just do that? And it's because the data science and the machine learning workflow needs cross all these different boundaries. So you should defend your right to have your own way of treating it. That would be sort of a thing I would encourage. But the other thing is also, there's a really great blog post. I keep pointing people to this. Eric Olson from Stitch Fix has a blog post called "Beware the Data Science Pin Factory," which is that once you put some workflow automation tools in place, and once you put in place the steps of what you do, there's going to be a temptation from management to manage you to that workflow. They're like, oh, here we now finally have laid out all these unicorns, the data science unicorns. We now have an X-ray of of what their actual workflow looks like, and we can optimize them for these different things. And that's the thing to just be aware of, is that once you put in workflow automation, people might be tempted to automate you out of your job, and so you have to defend yourself from that too.
Yeah, absolutely, especially with AutoML. All right.
Yes.
Thanks so much for joining me.
Thanks for having me.
Here to getting kicked out of the room.
Yes,
It was a lovely talk.
So great to talk to you. Take care.
You too. Bye.
Bye-bye.